Tell us your name and tell us about your project.
My name is Edward Morley, and my partner for this other half of the experiment that we that ended up being called the Michelson-Morley Experiment is Albert Michelson, and we attempted to detect a medium through space called an ether. And we tried to detect an ether wind, and that's what our project was about.
What were you guys trying to do or find?
We were trying to detect an ether wind since we knew at that time light acted as a wave. So like if you were able to like shine a light through a slit, and you could see how like in the middle it's a lot brighter, and then as you go out it you can just tell like as like how a wave kind of would act. So since we knew light behaved as a wave, we wanted to detect like how it was through space, so how it traveled through space. And since waves travel through a medium as like a sound wave travels through the air, or sometimes like underwater too, sound can travel. So we were trying to detect that ether wind, and that's what we were trying to detect in our project, is our goal.
Where did the project or experiment occur?
It occurred in 1887, and it occurred in Cleveland, Ohio at a university. Or 1877, excuse me.
What other significant events were happening around the world at that time?
I know here in the United States, obviously it was 100 years since our independence from Britain, so we were still getting our voting down. And I think Congress just passed the electoral vote. So because, I don't know, I guess everyone was concerned about their votes, but also I heard about Pearl Harbor being constructed or something like that, a naval base, a new naval base that we have. So that's going to be built soon, I guess. I don't know how that goes. And then also heard in Paris they were constructing an Eiffel Tower. I've seen some type of, I guess schematic or just like a sketch of it. And it looked really nice, so I'd like to see that one day. I also heard about some type of film being patented finally, so we're supposed to be able to watch film through a peephole with like light, and it's going to be an image from what I've heard, something like that. Other than that, I'm not too sure what else is going on around the world.
Who else was involved in the project?
Albert Michelson, he was my other partner. We had a couple, like just morale boosters around, like, our pets would come and not be in the actual lab, but, just go into the office and just kind of, give us that morale boost every now and then. But it was just me and Albert.
What was your role in the project?
Well, we both shared equal responsibility because we wanted to ensure that we were both able to, fill or try to, I guess, carry out an experiment if one of us was to not ever show up for any reason. So we both had equal responsibilities, but this is what we had actually did. So we have a mercury pool here, and this is all in a mercury pool, so it's not affected by like any type of like, I guess, like a balance or anything like that. So we shined a light to a half silvered mirror, and so that's going to allow for half of it to travel straight, but then other half is going to be deflected upwards like this. And so they're both going to, and then we're going to deflect it back to a mirror on both sides, and then those will go to a detector. So what we were thinking, since light acts as a wave, if the ether wind was traveling this way or that way or that way or some other way, it has to affect the light in a way, right? So they'd have two different velocities, or the detector would detect them at two different times. And what we came up to finding is that that they would arrive at the same time, no matter the time of day or just the time of season. So we waited like a full year, half a year, 6 months, whatever it may be, because the Earth shifted and we knew that, and tilted. So since we couldn't come up to, I guess, kind of, still stumbles us now because, we thought there was a wave because it had properties like a wave, but it also acts like, I guess, as something other than that. So that was our experiment, and that's what our roles were, was to try to carry out and see if we could get different reading for the light that was reflected upwards from the half silvered mirror and the one that traveled straight through it. But it came out to be the same result every time.
What impact did your project have on the physics community?
So in this case, we know that, I guess, the ether does not exist. Well, no, it does not exist. We know that it does not exist in this case because, like I said, the ether wind would have had some type of effect on the velocity, which it didn't. So that's what I feel like, so that verified that. So then, I mean, that was an important part in the physics at that time. I mean, so we had to continue onwards. We know that is not valid. So we know we can rule this out.
Is there anything that you would have done differently?
I don't believe so. I feel like what we came, like the conclusion that we came to, like I said, it's not what we wanted, because when you carry something out, you expect to your calculations to come out right because you're putting so much effort into it and it makes sense in your head. But I mean, it just wasn't. That's just how it came to be, and that's how, I guess, science is sometimes, for the better or worse. in our case better, because now it brought another question as to what's really driving the universe. I guess someone will have to, hopefully someone, as science progresses, someone will come along and answer the properties and why it acts like certain ways.